Good morning, one and all. Today, from mechanics, we discuss few concepts like gravitational field intensity, its graphical representation, concept of work, power, various units, and so on. Here, first concept is gravitational field. Gravitational field is a model. It is used to explain the influence that a massive body extends into the space around itself, producing a force on another massive body. Here you see this picture. It is a picture of Earth. It is given Earth is a massive body. And you know there is an influence of this massive body, Earth, around itself. Because of that influence, there exists a force, we say, on each and every massive body in its surrounding. Such a field is said to be gravitational field. See, you know, every body, when you are released from certain height, it comes to Earth. The reason behind it is what? Because of its influence on another massive bodies. That is said to be gravitational field. Now let us come to this graphical representation of gravitational field. You see along x-axis, it is given distance of the massive body from the center of the Earth. Along y-axis, it is given what? Force. I mean, force is a dependent quantity on distance from the Earth. I mean, distance of the body from the center of the Earth. Here it is given. R stands for the radius of Earth. 2R, twice the radius. 3R, thrice the radius. 4 times radius. 5 times the radius, and so on. Suppose initially the object is, or a massive body is at a distance of 5 times radius, 5R, from the center of the Earth. Then what happens? If we go from this point parallel to the x-axis here, you will get here force. I mean, this force is what? Less. Now you come towards 4R. Here point, if we take, here what happens? Force increases. In the same way, when the point or object or massive body is on 3R, at a distance of 3R, then what happens? Here force is increasing. I mean, gravitational force on the massive body is increasing. In the same way, at 2R, this point you will get. Here you see the quantity of force. Amount of force is increasing as we bring a body or massive body towards the center of the Earth or towards the Earth. Now here, if the body is at R, at a distance of R, in the sense it is on the surface of the Earth, then here you see the gravitational force is what? Very high, very large, more we say. From this it is clear that this gravitational force increases if the massive body is coming towards the earth, and if the massive body is going away from the earth, gravitational force decreases. This point we remember. Thus, a gravitational field is used to explain the gravitational phenomena, and it is measured. It is SI. Its SI unit is Newton per kilogram. Now let us turn gravitational field intensity. Gravitational field intensity at a point is the force that will be expressed by a unit mass when placed at that point. It is denoted by letter E and its unit is Newton per kilogram. Its mathematical expression is E is equal to gmr upon a square plus r square whole raised to 3 by 2. Then question arises, what is G, what is M, what is R, what is A? Here it is written G, gravitational constant, M, mass of the ring, distance of the massive body from the center of the ring, and A is what? Radius of the ring. It is shown in figure. Next slide. What is A, what is R? You see here. This small a is shown here. This is nothing but what? Radius of the ring. And this small r is nothing but distance of a point mass from center of the earth. This is nothing but the angle here theta. Here this is the ring having center O and radius A. So here gravitational field intensity is to be obtained by using this relation gmr by a square plus r square whole raised to 3 by 2. Now let's turn towards gravitational energy. Gravitational energy or gravitational potential energy is the potential energy of a massive object has in relation to another massive object due to gravity. It means it is the potential energy associated with the gravitational field which is released when the object falls towards each other. This potential energy is denoted by letter U, and its mathematical expression is U is equal to m into g into h. Again, where m is mass of the body, g stands for gravitational field, and h stands for the height of the body. You know law of conservation now. Law of conservation of energy states that energy can neither be created nor destroyed. Only it is converted from one form of energy to another. See, whenever a player kicks football, then his physical energy, muscular energy we say, is going to convert in the mechanical energy. Only there is a conversion of one form of energy to another. So this is nothing but law of conservation of energy. Now let us turn towards the concept of work. Actually, work is a measure of energy. Work is a measure of energy transfer. Measure of energy transfer from, or which occurs when an object is moved over a distance r by external force F, at least part of which is applied in the direction of the displacement. See, whenever object is subjected under force in a particular direction, and if object is displaced in the same direction, then the amount of energy utilized, such a measure of energy transfer to displace the body, is said to be work. Sometimes what happens, the force applied in a particular direction, but displacement we can't get in the same direction. In such a cases, applied force and direction of the displacement, they are not in the same direction. It means there exists an angle between them. Let this angle is theta, angle between the direction of the applied force and the displacement of the body. Here you see, here force applied is in this direction, displacement of this block is in this direction. This is initial position, this is final position, there is a formation of angle theta. If we obtain trigonometric relations, mathematical relations, then we will get work is nothing but F into R into cos theta, cosine theta, where F is force exerted on the body, theta is the angle between direction of force and direction of displacement, and where R is the what? Displacement of the object as shown in figure. In this case, work is given by F R cos theta, and if work is displacement is in the same direction of the force, then work is nothing but F into R, that is force into displacement. In that case, cos theta, theta becomes 0 and cos 0 is 1, that's why work is equal to F into R. Now, let's turn towards the power. Work is power is amount of energy transferred or converted per unit time. The SI unit of power is watt. 1 watt is equal to 1 joule per second. Power is a scalar quantity. This point you remember. And power is nothing but work upon time. So work upon time. Work is nothing but force into displacement. We have already seen. Time this. Therefore, power is equal to F into R by T. So force as it is, displacement upon time is nothing but rate of change of displacement is nothing but what? Velocity. So power is equal to force into velocity. Whenever question is asked in examination, work and time are given, power you can calculate. Force, displacement, time given, power you can calculate. Here force and velocity suppose given, then power you can calculate. Any two quantities are given, then third can easily calculate or obtain by using this relation. So in this way, so there are again different types of forces, conservative forces and non-conservative forces. Conservative forces are such as gravitational force, elastic force, electric forces are the conservative. Non-conservative forces, friction, air resistance, tension in cord, motor or rocket, propulsion, push or pull by a person. So in this way, these are the various concepts we have seen in detail. Thank you.